We have this matrix M, and reading the instructions, it says find the determinant of M. Now, if you notice, in the row 1, column 1 position, you have A. In the row 1, column 2 position, you have B. Row 2, column 1, you have C. Row 2, column 2, you have D. And it's a square matrix. If it's not a square matrix, you can't find the determinant. Watch out for that. So, to find the determinant, which we represent as det M, the matrix, or you can say the matrix and you put the absolute signs on it. So, to determine the determinant, you use this formula, A times D, which are the elements that are along the leading diagonal. And when I say leading diagonal, I mean this. Right? So you have A times D, and you're going to subtract from it the product of the off diagonals. And when I say off diagonals, I mean this. Right? That's what I mean by off diagonals. And product means you're going to multiply. So it's going to be A times D, work that out, subtract B times C. Right? This is a simple formula to calculate the determinant of a matrix. So we're going to work out an example. Let's put A here. And let's say I want A to be -1, -2, 3, and I'm going to say 4. To find the determinant of A, which can be written as this, we need to, this is in the A position, this is in the B position, C position, D position. Remember now, you need to find A and D and multiply them. So, A in this case is -1, and I'm going to multiply it by D in this case, which is 4. Then it says subtract. Put back my subtract sign. Notice that I'm following the formula. The product of B and C. In this case, B was 2. Not 2, but -2. Watch out for that. Just like how me nearly made a mistake, the exam will catch you like this. And we're multiplying that by C, which is 3. And I'm going to take my time and work it out because I don't want to make any more mistakes. So, a negative times a positive will give me a negative. And 1 times 4 will give me 4. That's that. I'm working the brackets first. So, negative times a positive will give me a negative. And 2 times 3 will give me 6. And I'm putting that in brackets. And I'm not forgetting this negative sign. Then now I can work out everything. A negative reverses a negative, so we end up getting a positive. So this -6 becomes a +6, and we'll have this -4 from before. So if I owe 6 and if I owe 4 and I pay up 6, then that means I have a balance of 2. And if I have it, then it's a +2. Easy. So we're looking at singular matrices versus non-singular matrices. And simply put, a singular matrix is a matrix that has a determinant that is equal to 0. So once you find the determinant of a matrix and it's equal to 0, then you can describe that matrix as a singular matrix. When you have a matrix with a determinant now that is not equal to 0, we describe it as a non-singular matrix. Let's look at an example. So here it is, we have another matrix and the instruction says find the determinant of the matrix Q, and this is Q. So number one, we need to find the determinant of Q. And then it asked us would we describe matrix Q. To find the determinant, which is absolute value of Q, is equal to, you say, A times D minus B times C. And I'm going to label my ABCD values. So this one is going to be A, this one is B, C, and this one is D. So I'm following the formula step by step and I'm not rushing. So A is 2, and I'm going to multiply that with D, which is 3. Then I'm going to subtract B value, which is 1 in the matrix, and I'm multiplying that by C value, which is 6 in the matrix. So I'm just following the formula, using it to guide me. 2 times 3 is 6. Take away 1 times 6, which is 6. Following the formula step by step, 6 take away 6 is 0. So the determinant of Q would have been 0. But are we finished answering the question? No. We just determined the determinant. We need to describe it. So because the determinant of the matrix Q is equal to 0, we can describe Q as a singular matrix. So once the determinant of a matrix is 0, it is described as a singular matrix. Let's run another example. It says find the determinant of matrix P, and how would you describe matrix P? And here is matrix P. So it asks me to find the determinant. So that means I need the determinant formula. So the determinant of P is equal to A times D subtract B times C. And that means I need to label my ABCD values. So this is A, this one is B, this one is C, and this one is D. So following the formula, A is 2, and I'm multiplying it by D, so D is also 2. And I'm putting them in brackets to show that I'm working them out first to find what AD actually is. The formula then says subtract B, and the B value is 1, times C, and our C value is 3. So I'm just keeping my formula, working with it. 2 times 2, that's 4. Subtract 1 times 3, that's 3. So the determinant of P is equal to 4 minus 3, which is just 1. And we just finished finding the determinant, but that's not all. It says that we need to describe the matrix. If the matrix is equal to 0, if the determinant of the matrix is equal to 0, then it's a singular matrix. But this is not 0. The determinant is not 0. Therefore, P is non-singular. That means P, the determinant of it, is not equal to 0. And that's it.